করতে হবে নাকি ওটা ঠিক করার
Yes,
পরে?
yes, yes. After that, you need to again recompile the code, and it will go to the fourth line, and it will show you the error that is happening in the fourth line.
Okay, sir.
Okay, that's it. Okay, so let's start with the today's content. So today I will first talk about the basic component of the computer. So everybody ever see the physical computer, but actually if we talking about the block diagram of the computer, in the block diagram of the computer only consists of the key components, not the entire thing. That is the primarily used, that is the key component. So just a minute. Okay. So the major part of the computer is the central processing unit or the CPU. Okay. So if we want to perform some tasks in the CPU, we have to give some instruction. So how the instruction will come into the CPU? Through some input devices. So that's why this arrow is directed to the CPU, and after performing the tasks inside the CPU, if we want to display the tasks or send the message, so it will be returned to the CPU, and there is a output devices. There will be many output devices are being present through which we can display our desired result or we can perform the output. Now, what are the input devices? The input devices is the keyboard. Through keyboard, we can type the text to the computer. So, one input device is keyboard. Next is mouse. Third one is mic. So, my voice is capturing by the mic and comes to the CPU, and after that, it comes back to you. This is the mic. Another one can be a scanner. And if we are talking about some output devices, like this is the primary output device is our monitor. Next, it can be a speaker. There might be a printer. So these are the output devices. Now,
Sir, sorry to interrupt. Somebody's mic is on and it's creating a feedback on my speaker. Sir, somebody has a mic on.
okay, just let me
Tanmoy,
check.
switch off your mic, please. Okay, switched off.
Okay, fine. Okay, now in the CPU, what are the major components? In the CPU, we have a major part is consist of the processor. The processor is the key component of the CPU. Sorry?
Sir, your voice broke, sir.
Or maybe the internet connection gets poor. Now it is okay?
Now, okay, sir, it's okay.
Okay. So the major component consists of a CPU is a processor. What is a processor? Processor is the component which process all the operations. What are the operations the processor can process? Are logical operations and the arithmetical operation. Two types of operations. So processor will do arithmetical operation and logical operation. What is the arithmetical operation? In mathematics, what are the operations we are performing? Like addition, subtraction. So these are the operations. This comes under the arithmetic operations. And what are the logic operations? Logic operations are logical and or and not. Okay. So what is logical arithmetical operation. Arithmetical operation is used to handle the arithmetic operation, and the logical operation is also bundled with the arithmetical operation. I will show you an example. Let's say start with a multiplication in computer. So I have taken two values to multiply. So let's say 11 into 11. So I am taking about our mathematics, not the computer mathematics, the 11. So what I do, 1 into 11 is 11. After that across, and then this is a 11. So after sum of them, we will do 121. Okay. So what is actually happening? The first operation we have performed with this 1 will be multiplied using this row. So what we get? We will get 11. After that, there is a cross. So the cross means a shift operation. We have shifted, we have left shift operation. Okay, and we will again operate on the another one, that is, just let me change the color. So this one with this row, and what we get? We get 11. After that, we will sum two rows, that is this row and this row, and finally we get 1 to 1 as an output. So these are the few operations are being performed. Now the CPU will perform all these operations. Out of them, the multiplication operation is comes under arithmetic operation, and one shift operation we have performed for the next element, that will come under the logic operation. Okay, I hope you can understand that what is the difference between arithmetic operation and logic operation.
স্যার লজিক অপারেশনটা ঠিক মতো বুঝলাম না স্যার, এই অ্যান্ড আর নট বলতে স্যার ওটা একটু বলবেন?
The AND or not আমি এখনো বলিনি. Logic operation is consist of AND or not, also the shift operations. Also the shift operation. So shift operation example, I hope you can clear the example before the right multiplication result comes out. We have to do some shift operation. In the next line, if we are trying with the 3-bit number or 3-digit number multiplication, in that case, for the next row, we have to say twice, as we do in our normal mathematics. Now tell me what you are trying to say.
এই 11 into 11 যে প্রসেসটা বললেন স্যার, পরপর ওইগুলো একটু আরেকবার একটু বলবেন স্যার?
Okay, taken another example. So let's say I have 1, 2, 3 is an first input, and second input is 1, 1, 1. So what first we do? We are going to multiply to 3-digit number. So first what we do? First, this is the 1. This 1 will be multiplied with 1, 2, 3 for each bit. So what the result we get? 1, 2, 3. Okay. For the next one, before the multiplication start, we have to do one thing. We have to do a shift operation. So that is this bit is not required for this step of multiplication. Okay. After that, this one will be multiplied with 1, 2, 3, and we will get the result. Now, for the third one, when we are going to multiply, that will be x 2 shift operation. Now, what we get? 1, 2, 3. After that, what we get? We have to sum up them, and we will ignore the shifted part. We will assuming that nothing is present here. Nothing means in computer, nothing is treated as a 0. So when computer will sum up them, that is this column sum, when it will perform, then the xx position will be filled up with 0. We know that if we add something with 0, the result will not change. So what we get? We get 3 over here, we get 5 over here, and we get 6 over here, we get 3 over here, and we get 1 here. So that will be the final result. So out of them, what are the operation we have performed? We have performed multiplication, then shift, and also at the end addition. So these are the 3 operations has been performed to get the correct result. So out of them, multiplication and addition comes under the category of arithmetic operation, and shift is coming under the category of logic operation. Okay, so I am trying this one. So multiplication and addition comes under the arithmetic operation. And shift comes under the logical operation. So both the operational circuit are being embedded inside our processor. Only the arithmetic circuit will not be performed the any type of operation unless we have the logic circuit inside it. So the CPU is consist of processor, which is primarily consist of two different circuits. One is the arithmetic circuit for arithmetic operation and the logic circuit for the logic operation. I hope it is clear to you. It is clear now?
Yes, sir.
Okay. Now we have seen the block diagram of the computer. This is we can say the block diagram. Block diagram of our computer. Now we have seen that CPU input-output devices are being present, but there is another important component of the computer is the memory. If we don't have the memory, we cannot do any operation. The memory is not for storing the data. Memory is also used for the operation. So memory is another key component. So see the memory. Now tell me if we are going to add 10 plus 20 plus 30. So you can tell me that it is not required any memory to get the output because we have 10, 20 and 30, we can directly write 60 for the result, but the thing will not happen. Why? Because the 10 will be stored in some of the memory, 20 will be stored inside the memory, and 30 will first store inside the memory. So memory is important before starting to any operation. After that, what will happen? Computer will first add 10 and 20 and 30 will be stored in some of the memory location, and after that this 30 and this 30 will be added and we will get 60. So in this way computer will perform. If we are talking about parallel processing, that means we can do the parallel tasks. So the time requirement will be less, but the thing is that the thing will be performed in this way what I have just now said, told to you. So this is the way that computer works, and in each of the step we record the memory. In each step we required memory. So now you can understand that how important the memory in the computer. In the primarily what we see that if we have memory, we can store the data for future, but it is not correct. It is not 100% correct because memory is also important for minor operation also. Okay, understood, everybody?
Sir, I just have one question.
Yeah.
I'm okay with the memory part and the input and output devices that you explained. Can you go a bit up and go a bit on the top where you were explaining the multiplication and the addition, arithmetical
Yes.
and logical operation? That part, and or not is fine, but I just want to know that multiplication bit that you did. Can you just refresh that once more, please?
This multiplication part.
Yes, sir. Yes. Just explain how the computer
Yes.
sees it and how it works on it.
Yes, computer also works what a human is also doing. That means first 1 will be multiplied with 1 to 3 and the 1 to 3 will be stored in some of the memory. Okay, so this 1 to 3 will be stored some of the memory. Okay, after that for the next one it will be multiplied with again 1 to 3, but before the multiplication we will do some shift operation as we do in our copy, and after that it will be stored in another memory. Similar tasks for happen for the last one, that is this one. When this one will be multiplied with 1 to 3 and the result will be stored here, but before the store it will be shifted twice to get stored into the memory. After that, the 3 results are being stored in 3 different memory components, and after that the memory component result will be fetched, and finally we will get the actual result. Now I hope it is clear to you.
Yes, sir. Just one thing, there would be a different command for having this multiplication signs fed to the computer so that it understands that it has to shift one place and then next 2 place to make that format, right?
Yes, there is a circuit are being present when in the third
Yes.
semester we will learn the computer organization. In
Right.
that area, you will get the detailed circuit details that how the shifting will happen and everything.
Okay,
And you have a dedicated lab also. You
Right,
can
sir.
take some hardware components and you can also have hands-on experience that how the circuit will be built up.
Okay.
Sir,
And also
Sir.
there'll be the particular commands that will also be there which will be used for this multiplication, isn't it, sir?
Yes, the command is being present like that star asterisk. The asterisk word,
Yes,
when we
yes.
use that 10 and 20, the computer will
Mhm.
give the 30. But the thing will actually convert it into this category to get the 30 result. In the software level, we will only provide a syntax, that is asterisk for the multiplication. But the thing
Right.
will happens in the hardware that I have just now described.
Got it, sir. Got it. Thank you, sir.
Okay. আর কে কি বলছিল বলো আরেকজন?
স্যার আই হ্যাভ আ কোশ্চেন স্যার যখন আমরা কম্পিউটারে যখন আমরা এই মানে কোন প্রোগ্রামে আমরা মাল্টিপ্লিকেশন ইউজ করি তখন ওই সার্কিটটা ওই প্রসেসরে যখন যায় কম্পাইলার এটা এরম ভাবে কি কম্পাইল করে সার্কিটকে পাঠায় না সার্কিটই নিজস্ব ভাবে এরম ভাবে মানে করে আউটপুটটা রেজাল্টটা প্রিন্ট করে
No.
মানে এই
What
জায়গায়
compiler?
কিভাবে
Okay, I understand.
কম্পাইলার কিভাবে
After compilation, the process will get into instruction. Okay, so whatever, let's say, take an example, simple example. Let's say I have a equals to, like in your algebra, a equals to 10, b equals to 20. Okay, and you are writing as x equals to a plus b. So whenever this piece of code will be comes under the compilation, it will be converted into 3 different instructions. So 3 lines you have written as your primary code, and it will be converted into 3 different instructions. Okay, just a minute. Okay, sorry for the inconvenience caused. Now my voice is clear. Can you hear me?
Yes, sir. Yes, sir. We can.
Yeah. So what I am telling, so you have written 3 different instructions for performing addition of 10 and 20. So what will, after compilation, what will do? The compilation converted into 3 different instructions. I am telling as I1, it will be as I2, first assuming, and this will be for I3. So what I1 will tell the instruction, I am not writing the instruction in format rather than some English sentence. So store 10 inside A. So instruction 1 will be tell to the hardware that first store 10 inside A sum of the memory block where A will be stored. After that, what I2 says I2 says that store 20 inside B. Okay. Now for I3, what will say the computer? Add value of A and B. So what will do? So this is the third instruction of the I3 will say the operation. Actual operation will be comes under the I3 part. That is the instruction, third instruction. In third instruction will A is 10, we know that, before that we have declared it. B is 20, now it will perform plus 10 and 20 and we will get 30. And 30, what 30 will be get? So also there will be same instruction, that is store A plus B in X. So we will store A plus B, that is the value 30. 30 will be stored here, where 30 will be stored inside X. So after compilation, it will convert into the machine understandable instruction, and after that your underlying hardware will work like processor. Understood?
Sir, what you told, sir, now, sir, can you repeat? Means last line means X equal to A and B. After that.
Okay, so in I3 you have written that X equals to A plus B. That means you are going to tell the hardware to do the arithmetic operation like addition. So the instruction will be converted in such a way that add value of A and B. So you have previously declared A value as 10 and B value as 20. So 10 and 20 will be added, and also you have written that X equals to. That means after the addition will be performed, the result will be stored inside X. So that's why store A plus B in X.
Okay, sir.
So
Clear, sir.
So this instruction is actually controlling your hardware. Your program is for your understandable part. After compilation, it will be converted into instructions, and the instruction will be intercepted by the hardware, and hardware will perform as per the instruction. So if your program is getting wrong, the compilation will not be performed. Whenever you will provide the correct syntax, compilation will be done correctly, and it will use the instruction will come inside the hardware. Okay, fine.
Sir, this instruction is needed to be stored in some of the memory. So how computer manages this memory, means how it knows that here it is, I should store this memory here. Means
No,
how
no.
this.
So in computer processor, so let me first discuss the memory part. Then you have the idea that where the value will be stored and where the instruction will be stored, right?
Okay,
So
sir.
okay. So first talking about the memory. So in memory will be first categorically divided into two major broad categories. That is the primary memory,
Secondary memory.
and secondary memory. Okay, so if someone asks you to differentiate between primary memory and secondary memory, there will be a lot of things is written in the book. But the major difference of between the primary memory and the secondary memory is that primary memory is being directly connected with the CPU. So if you see the motherboard of any computer, you can see that the primary memory is your RAM. So RAM has been connected inside the motherboard, and if you see the secondary memory like your hard disk, you can see there is a wire connected with your hardware, with your hard disk, and another part of the wire has been connected into the motherboard. So what is the basic difference between the primary memory and the secondary memory is that primary memory is being directly connected with your CPU, whereas secondary memory is also connected by some of the wire connection is being present. So what is the basic difference is consists primary memory is pretty fast because their fabrication or when they have been created in the industry, they have used different materials by which it will provide you the good speed. But in the secondary memory, compared to the primary memory, the speed is very less. But what is the advantage of the secondary memory? The cost of the secondary memory is very less. So nowadays, 1 GB hard disk price is around 3,500. So this is the average price of a 1 GB hard disk. And if you just 4 GB RAM, the cost of same as the 1 GB hard disk. Because the RAM is a primary memory. Fabrication technique in the industry, it uses different types of materials. So the total cost is compared to a 4 GB and the 1024 GB as compared to 1 TB of hard disk. So now, what is in the primary memory? If we are talking about next category of the primary memory, the primary memory is basically 3 types. One is the RAM, that is the random access memory. Another one is the ROM. And third
Read-only
one is
memory.
the read-only memory. Another is the register memory. Okay. In the secondary memory, there will be a lot of options is available in your site. One is the hard disk type. We have the CD or DVD. We have the floppy, but nowadays it is not used.
Sir, in place of floppy, we can say pen drive, no?
Yes, pen drive is also another example of secondary devices. Now, RAM and
May I ask
ROM
one
is
question?
yeah.
স্যার
Yeah, go
আমরা
ahead.
স্যার ক্যাশ মেমোরিটাকে স্যার কোন কোন ক্যাটাগরিতে ফেলতে পারি স্যার?
হ্যাঁ স্যার, ক্যাশ মেমোরিটা কোন ক্যাটাগরিতে হবে?
বলছি
রেজিস্টার।
নেক্সট কম্পেয়ার টু রেজিস্টার। ওকে, আমি এখন পুরোপুরি ফাইনাল আনসার দিচ্ছি না, বলার পরে
স্যার
বলছি।
পেন ড্রাইভের উপর ওটা কি লিখেছেন আমি কিছু বুঝতে পারছি না।
ফ্লপি
Floppy.
তার আমি আরেকবার লিখছি। Look one thing, random access memory of the RAM. So how we can differentiate between RAM and ROM, which is very important. Difference between RAM and ROM. So the first, if we talking about the abbreviation, that is one is random access memory, random access memory. Another one is the read-only memory.
only memory.
Yes, read-only memory. Now next is the, if we store something inside the ROM, if we switch off your computer, that means after getting all the power, the ROM memory will not be disrupted. But if you store something in the RAM, after switch off your devices, the total memory will be washed out. That means completely the RAM will be washed out after powering of the devices. So that's why whenever our smartphones is getting hanged, when we restart our phone for few hours, the performance will be boosted because the RAM will be washed out and total memory will be free and gradually it will be free. Someone have unmuted his mic, please mute it. Yes, sir.
Mohammad Muharram.
Sir, can you repeat the last point of difference?
দাঁড়াও, আগে ওর মাইকটাকে মিউট করি।
Muharram, please turn off your mic. হয়ে গেছে স্যার, করে দিয়েছে।
I am telling that if you store something inside the ROM, if you switch off your devices, the memory will not be disrupted or any changes will not be made inside ROM. But if you store something in the RAM, it will be deleted when the power goes off. So that means RAM will be updated or RAM will be keep storing the data until you are putting the power inside the chip. But in the ROM circuit, if you put something when the power is on and if you power it off, the data will be remain constant inside the ROM. Okay. Next major difference between the RAM and ROM. So the word volatile is being used. Volatile means the thing will be washed out, that I have already told. So RAM is a volatile memory, ROM is a non-volatile memory.
স্যার এটা একটু রিপিট করুন, মানে ভলাটাইল আর নন
ভোলাটাইল মিন্স যখন তোমার পাওয়ার চলে যাবে সেটা ডিলিট হয়ে যাবে, সেটাকে বলা হয় ভোলাটাইল। ভোলাটাইলের বাংলা হচ্ছে উদ্বায়ী, যেটা বাতাসে উড়ে যায়। ঠিক আছে। আর ROM is a non-volatile. Another example is that random access. It has the capability for randomly access. Random access means two type of access is being there. So when we the teachers are usually take the attendance, we will use the serial order. That means 1, then 2, then 3. So this is a serial access or the sequential access. But when we have talking that roll number 1, then roll number 11, then roll number 33, so that is access is called the random access. So RAM have the capability to access the block of the memory randomly. That means it can go anywhere of the memory to fetch the data. That is a special capability of the RAM. So that's why RAM prices higher than the ROM price. So these are the differences. You can search on the internet, or you can see any standard books of computer. You can see those differences between RAM and ROM. Now talking about the next one, that is the register. The register memory is actually the memory of CPU, the processor memory. So i3 processor have the i3 is a processor, and if you talking about the memory of i3, that will be the registers. So registers memory are limited because it's very costly memory. So another one is that you have told about the cache, right? So cache is another high cost memory, but that is not similar with the register. Register is different, cache is different. Okay.
So somebody said, sir, cache is registered.
No,
No,
that is
group.
completely wrong.
Yes.
The register is the processor memory. Okay, processor own memory. And what is cache? Cache is introduced just beside the registers for better performance. So there will be a cache mapping techniques are being present. You will learn this part on the third semester computer organization. Okay, now it is very difficult to understand what is how the cache really works in the computer memory. But one thing for your state, you have to understand the difference between the register and cache. They are not same. Register is the processor own memory, whereas cache is being introduced for the better performance.
Okay, sir.
So these are the memory parts. So if we are talking about the hierarchy of the memory, in the hierarchy of memory, I am just this is the memory.
Sir, I have one question.
Okay, go ahead.
Sir, can we put the cache memory in the primary memory segment?
Yes, cache is a primary memory.
Okay, sir.
Cache, register, RAM, ROM, both all four are under the primary memory because they are directly connected with the CPU. Okay, these are the memory hierarchy. In the bottom level, it will have the secondary memory. That is the secondary memory. Secondary memory. I am not writing all the different types of secondary memory. Only available secondary memories are being present at the bottom. Next is the cache. Next is the RAM ROM. Here is RAM or ROM. Here is the cache. And here is the register. I am not writing the inter register. Now, if we have draw some lines for the analysis, in these lines, what will happen when we go top to bottom? That means in this pyramid, if we have staying at the top, and when we go from the bottom time, what we have seen? We seen that memory size increases, right? Memory size increases. That means the register have a very small availability after that cache. The RAM and ROM have the availability like 4 GB, 8 GB, and secondary memory like 1 TB. And also the cost getting less. Cost getting less. So this is the one type of analysis. And if we go from bottom to up approach, that means memory sizes decreases, right? If we compare with secondary memory and the cache, there is a hell and heaven difference between a secondary memory having 1 TB, whereas cache is 4 MB, 8 MB maximum. So memory size decreases. Yes. And also cost getting high. Cost getting high. So I am just writing some standard size that is not fixed. In a standard laptop, if you see nowadays, 1 TB of secondary memory. Next is that RAM and ROM having 8 GB or 16 GB. Cache memory is 4 MB or maximum of 8 MB. And register availability is, what we say, the KB, let's say 256 KB. And if you talking about the prices, 1 TB hard disk prices nowadays is,
2.5K, sir.
yes, I am writing 3.5K.
No, it's around 2.7 or 2.8.
Oh, it's
Okay,
3K,
so
3K.
in standard 3K or 3.5K, what I have written. In RAM ROM, it is around 4K. If we are talking about more than 4 to 6K. In cache memory is actually bundled with the nowadays in the CPU. So together the register processor prices around 18K to standard processor 18 to 40K. So you can see the prices jump if we are going top or bottom to top approaches of this memory. So this is called the memory hierarchy. Memory.
স্যার আমরা তো এটা স্পিডের বেসিসেও বলতে পারি যে উপর থেকে যখন নিচে নামতে থাকবে স্পিড কমতে থাকবে।
হ্যাঁ অবশ্যই ওটাও লেখা হয়নি, লিখে দিচ্ছি, ভেরি গুড।
হ্যাঁ হ্যাঁ।
The access speed is also getting high when we go top to a bottom to top, and speed is
From bottom
getting
to
low
yes sir, yes sir.
or top to bottom. So memory hierarchy.
স্যার একটা জিনিস জিজ্ঞেস করা ছিল, এখানে এইচডিডির সাথে এসএসডিটা ওর মধ্যে ইনক্লুডেড থাকবে না সেকেন্ডারি মেমোরির মধ্যে?
হ্যাঁ হ্যাঁ হ্যাঁ।
না SSD রাইট। SSD টা কি? SSD টা কিন্তু প্রাইমারি মেমোরি নয়, সেকেন্ডারি মেমোরি। কিন্তু SSD যে ফ্যাব্রিকেশনটা হয় তাতে কি থাকে, ডাইরেক্ট একটা চিপ থাকে। আমাদের হার্ড ডিস্কে কি থাকে, প্লেট থাকে, প্লেটের জন্য একটা মোটর থাকে।
স্যার একটা জিনিস একটু জিজ্ঞেস করা ছিল, আপনি যেটা বললেন যে SATA কেবলের থ্রুতে মাদারবোর্ডে কানেক্টেড থাকে এইচডিডি, বাট এসএসডি তো এখন অপশনে আমরা M.2 যেটা আমরা ডাইরেক্টলি মাদারবোর্ডেও কানেক্ট করতে পারছি, তো ওটা কি সিস্টেম হচ্ছে?
দেখো SSD টা কি, SSD is a secondary memory. Don't mess up with the primary memory, but the fabrication technique of SSD is close to the RAM. RAM যেভাবে fabricated হয়, SSD ও fabricated হয়। এটা ডাইরেক্ট তোমার CPU যে পিন থাকে, যে পিনের সাথে ডাইরেক্ট অ্যাটাচ করা যায়। তার জন্য SSD হচ্ছে better speed. This is the only not a single reason for better speed, and also SSD have a solid state drive. So the full form of the SSD is solid state drive. So there will be no magnetic component are being present as we compared with the regular SATA hard disk. In the SATA hard disk, there is a motor. The motor will rotate the magnetic plates and the data has been fetched. So it will take the extra access time. So
স্যার আরেকটা জিনিস যেটা জিজ্ঞেস করা ছিল স্যার, এই পুরোনো ক্ষেত্রে তো এসএসডির ক্ষেত্রেও SATA কেবল আমরা ইউজ করতাম, তো সেই ক্ষেত্রে
no. Okay, when we purchase a SSD, the SSD is same, but in the previous generation laptops there will be no dedicated port in the motherboard. In that case, what we do, we have SATA connected cables to connect the SSD as we do in the regular hard disk. But the speed is compared to higher than the regular SATA drive. Okay, but nowadays whatever the motherboard is being present, here is directly pins are being present, and you can directly plug it into the motherboard. Okay.
Yes sir. Okay sir.
Sir, I just want to ask you something. The SATA thing and the SSD, it's not clear to me. Is it possible for you to just explain it once more?
Okay, in SATA disks, if you see a laptop having SATA disks, whenever you will use the laptop, you can see some vibration because
Yes.
there is a motor. The motor will rotate the plates because the SATA disks consist of 1,000 plates are being attached into the SATA disks, and these plates are in the moving parts. But in case of the SSD doesn't have any moving part. It will be like
So
a pen drive.
what is a SATA disk actually? I'm not clear with that concept.
Okay, SATA disk, the fabrication technique is like a pen drive. In pen drive, there is a chip is being present. The thing has been stored inside some flip-flops. So the flip-flops, what is unknown to you, you will learn in your basic electronics in first semester or second semester, the flip-flops are being stored the bit of information or data. So SSD consists of billions of flip-flops through which the data has been stored. And in case of the SSD, in case of the SATA disks, the things has been stored in the magnetic plate, like the CD. When you broke a CD plate, you can see a small plate,
Yes.
small thin plate. So this is called the magnetic disc. So the same thing is available in the SATA hard disks. The small plates are being attached. Not a single plate, there will be a multiple plates. But SSD is like a pen drives. So there is no moving forward. So the thing will be more clear to you in your second semester. There will be a slight discussion on this point. So so what today we have discussed the basic computer devices regarding the memory, different types of memory, and also there will be a different types of RAMs category are being there. That is the SRAM, static RAM, dynamic RAM. DRAM is better because whenever we have purchased a mobile phone, you can see that DDR3 there will be different version. Now DDR4 is being come to the market. So whatever the higher version we will get, you will get a
Sir,
better
DDR5 is also coming.
The DDR5 is also present in the market. So the higher version you will go, the cost will be higher, and you will get a better performance. Okay, আরেকটা কথা, তোমাদের আগের যে দুটো ক্লাস হলো, সেই ক্লাসের অ্যাটেন্ডেন্সটা কি কেউ স্ক্রিনশট নিয়েছো?
স্যার ওই চ্যাটে আমরা পাঠিয়েছিলাম আপনাদের ডিপার্টমেন্ট।
চ্যাটে তো স্যার পাঠানো হয়েছিল ওটা।
ওটা চ্যাটে তোমরা এত কিছু লেখো না, আসল কন্টেন্টটা হারিয়ে যেত। কেউ একজন একটু ইনিশিয়েটিভ নিয়ে আমাকে একটু পার্সোনালি পিং করো না হোয়াটসঅ্যাপে দুটো ক্লাসের স্ক্রিনশটটা। আজকে থেকে আমি ওই অনলাইনে নিয়ে নিচ্ছি, মানে এক্সটেনশন দিয়ে নিয়ে নিচ্ছি। আজকে থেকে না করলেও চলবে। আগে দুটো একটু
মানে
পাঠিয়ে
আগে
রাখো।
দুদিনটা।
হ্যাঁ, আগে ফার্স্ট ডে 1 এন্ড ডে 2।
আগের দিন একটা অনন্যা পাঠিয়েছিল মানে।
আচ্ছা, আমি হোল ক্লাসকেই বলে দিচ্ছি, যে কেউ একজন পাঠিয়ে দিলেই হবে।
হ্যাঁ, মানে একজনের কাছে রয়েছে, নাহলে খুঁজতে হবে, সেটাই স্যার বলছিলাম।
এখনই জিজ্ঞেস করে নেওয়া যাক না, যে কেউ যদি নিয়ে থাকে। কেউ কি নিয়েছিলিস তোরা?
আচ্ছা, আমি বলছি যে কারোর যদি ক্লাস থাকে তাহলে একটু পাঠিয়ে। আর তোমাদের ক্লাসের রেকর্ডিং হচ্ছে, অসুবিধা নেই। আমি রেকর্ডিংটা একটু প্রসেস করে তারপরে দিয়ে দেবো লিংকটা, ঠিক আছে?
ঠিক আছে।
ওকে স্যার।
ওকে স্যার।
ঠিক আছে, জাস্ট আ মিনিট।
স্যার বলছি এটা ডাবল ছিল স্যার। স্যার বলছি এটা তো আমাদের মাল্টিপ্লিকেশনটা গেল, এটা মানে যদি ডিভিশন হতো তাহলে কিভাবে হতো? মড ডিভিশন এইগুলোর জন্য এরকম প্রসেস আছে?
প্রত্যেকটা প্রসেসই এরকম ভাবে হয়।
একটু ইকো হচ্ছে স্যার।
ঠিক আছে, না ডিভিশন হচ্ছে আলাদা। ডিভিশন হচ্ছে সাকসেসিভ সাবট্রাকশন। তুমি যদি কোনো জিনিসে যদি ডিভিশন করতে চাও তাহলে কি করো? ধরো 4 ডিভাইডেড বাই 2, তাহলে তুমি কি করবে? 4 থেকে একবার 2 বিয়োগ করবে, ঠিক আছে? 4 ডিভাইডেড বাই ধরো 2 আছে, ঠিক আছে? তাহলে তোমার রেজাল্ট কত হবে? কোশ্চেন 2 হবে। এবার কোশ্চেনটা হচ্ছে তুমি কিভাবে ডিভিশনটা করবে। তাহলে 4 থেকে একবার -1 করবে আর একবার -1 করবে। এটা হচ্ছে কি? সাকসেসিভ সাবট্রাকশন। আর মাল্টিপ্লিকেশন কি? সাকসেসিভ অ্যাডিশন। 3 into 2, তার মানে 3 plus 3 বা 3 into 3, 3 plus 3 plus 3, ঠিক আছে? কম্পিউটারও ডিভিশন সার্কিট আলাদা আছে, অ্যালগরিদম আছে। এগুলো অনেক মানে টাফ জিনিস, যেগুলো তুমি হায়ার সেমিস্টারে কম্পিউটার সায়েন্সে পড়বে, ঠিক আছে?
হ্যাঁ স্যার।
ওকে, ঠিক আছে।
ছিল না স্যার, অ্যাডার ছিল না? অ্যাডার, সাবট্রাক্টর, হাফ অ্যাডার, ফুল অ্যাডার।
তুমি
ওগুলো দিয়েই হয়।
ওগুলো দিয়ে, রাইট। ঠিক আছে, এটা জেনারেল ক্লাস হচ্ছে, পরে যখন ডিপার্টমেন্টে পড়বে সেগুলো সব জেনে যাবে।
এখন তো বাকি আছে অনেকগুলো ক্লাস।
স্যার একটা কোশ্চেন ছিল স্যার।
হ্যাঁ, বলো।
স্যার ওই স্যার রেজিস্টার মেমোরি এবং ক্যাশ মেমোরি যে দুটো ছিল ওগুলো কি স্যার প্রসেসরের মধ্যে থাকে?
হ্যাঁ, রেজিস্টার আর ক্যাশ দুটোই হচ্ছে প্রসেসর। আগেকার প্রসেসরের মধ্যে কি আসতো? প্রসেসর আলাদা আসতো, রেজিস্টার মেমোরি দিয়ে আর একটা ক্যাশের চিপ বসিয়ে দেওয়া হতো। এখন এখন যে 11 জেনারেশনের যেগুলো আসছে সেগুলো হচ্ছে প্রসেসরের মধ্যে ফ্যাব্রিকেটেড হয়ে আসছে ক্যাশ। তাহলে ক্যাশের পারফরম্যান্স আরো বেটার হচ্ছে।
ওকে স্যার।
ঠিক আছে, ওকে, ইউ পিপল নাও লিভ। থ্যাংক ইউ।
থ্যাংক ইউ স্যার
থ্যাংক ইউ স্যার।
Thank you, sir.
থ্যাংক ইউ স্যার।
থ্যাংক ইউ স্যার।